Good evening, everyone. This is the Veer Maheshwar Charitable Trust Latur MS India organizing daily international webinar series. This series is running from last 5 years under the Women Empowerment series. Every day at 7 p.m. we'll join here for watching the sessions from the experts invited from India and abroad. So every day we are enriching in the knowledge on various topics related to education, law, environment, technology, mindfulness. These topics and every topic is accepted here. Today on 19th June, we have invited Dhanalakshmi A.J ma'am, who is founder at DigitCodemy, Bengaluru, Karnataka, India. Being the field in the technical field, she will deliver the topic on India's semiconductor mission, opportunities for students, startup and innovation. Being an IIT student, her expertise is the semiconductor, and in this session, she will give information about the opportunities for students for starting their startups and innovation. I welcome you, ma'am, from my organization and from all the participants, those who are joined here. I welcome all the participants, and we are ready to listen from our speaker, Dhanalakshmi A.J. ma'am. Welcome you. You can start your speech now. Thank you.
Thank you, sir. Good evening, everyone, and welcome to this distinguished international speech series. And this series is organized by, as Dr. BETKAR said, this is organized by Veer Maheshwar Charitable Trust. And thank you, Dr. BETKAR, for this opportunity. And today's session, India's semiconductor mission, the opportunities for students, startup, and the innovation. And I'm Dhanalakshmi A.J. and founder of DigitCodemy. It is a tech-ed experiential learning platform, and it covers everything from computational thinking till semiconductor innovation. I would like to share my screen and go about with today's presentation. Just give me a second. I hope I'm audible and my screen is visible to you.
Yes, ma'am, visible.
Thank you, sir. So today we will explore one of the most exciting technology transformations happening in India, the semiconductor mission. We will understand why semiconductors are strategically important at this point of time and how the global ecosystem works and what India is doing to build its semiconductor industry. And most importantly, what opportunities this create for students, startups, and the researchers in this domain. Yeah. So moving to the agenda part, here, let me briefly walk you through today's roadmap. We'll begin with why electronics and why semiconductor matters. And we'll also look into the global semiconductor landscape, understand India's semiconductor mission, ISM, and discuss opportunities for startups and students, and conclude with a discussion and networking session if time permits. If in case time exceeded, we can connect in LinkedIn, and I'm happy to answer your queries in LinkedIn. Yes. So, why electronics matters? Electronics has become the foundation of modern society. Whether we look at our smartphones, electric vehicles, renewable energy systems, medical devices, industrial automations, defense system, AI infrastructure, space technology, everything. Semiconductors are the heart of each and everything. In today's world, every major industry is becoming a technology industry. And so of course, these are the areas which I have listed. So as we can see, semiconductor impact is in multiple sectors. Rather than multiple sectors, it is almost in every sector. So no, it is really hard nowadays to find out a sector where electronics or semiconductor is not there, including agriculture and environment. So we are going towards the technology. We are utilizing the semiconductor to help solve the real world problems. So yeah, so this is why the countries across the world are investing heavily in semiconductor manufacturing and design capabilities. And this widespread influence explains why semiconductors are often called as the new oil of the digital economy. So earlier you are aware of the oil, the word oil. So now semiconductor is the new oil of the digital economy. And let me move to the next part, which is the global landscape. Semiconductor industry is a highly globalized ecosystem. So no single country is controlling the entire value chain. Rather, different countries specialize in different areas such as design, manufacturing, equipment manufacturing, materials, packaging, and testing. So let us go through deeply into what is that segment here is. If you look at the slide, US has 45% share of this complete semiconductor industry. European Union has 10% and Asia is 45%. If you notice inside the Asia, so we have China taking an important role, Korea, Japan, and Taiwan, of course, Taiwan. So where is India here? As of now, it is not there, but with the India Semiconductor Mission, we are almost like we are getting a place there in this map. So soon, mostly in the next year's YOL survey, we would be also be there in this map. And so now, what are the current fab or foundry system in the foundries are available here in the world, and what are the planned or projected fabs in this 2025 to 2030? Things the expected foundries. So you could see that covered in this map, and you could clearly see that how many fabs are there in US. US has some 11 plus fabs, and China mainland has 21 plus fabs. South Korea 6 fabs, etc. Japan has 3 fabs, etc. If you look at where India is now, India is getting one fab, which is in Gujarat by Tata Electronics in association with TSMC Taiwan. And Singapore has 2, etc. So you could see in the picture where the India is also is going to get a fab here. In the upcoming slides, I'll explain what is fab and what is a foundry, the differences, etc. would be covered. As of now, fab or the fabrication facility is a specialized factory where you can consider that as a specialized factory where raw silicon wafers are transformed into integrated circuits or microchips. And this is a multi-billion-dollar facility because they have very complex and atomic scale processes involved in it, like photolithography, etc. And in recent news, you would have heard about this photolithography device, and that is from the ASML, and Tata has signed up with ASMC in Netherlands. So we'll be discussing that also in the coming slides. And yeah. Next, moving to what is the segmentation under this one semiconductors. If I can just simply say a semiconductor industry, and there are around 20 lines of segmentation under the semiconductor industry, which can be broadly classified into 2 categories. One is more and more than more, where the memories, what we are having for the laptops, computers, mobile, and the memory section, that part, and the logic section, the processor units, etc., GPUs, etc., and AI accelerators. All these things comes under more section. And whereas the sensors, imaging sensor, optoelectronic devices, and power modules, analog circuits, all these things comes under the more than more segment of a semiconductor. Now, an interesting observation here is 73% of the industry belongs to what is called more technologies, and this is particularly used for scaling, performance, and integration. While the remaining 27% belongs to more than more, but still we cannot ignore this 27% because 27% of total $651 billion is not a less amount. And yeah, and but from this picture, it is very clear that where the money comes, it is from the more segment, which is memory, and that is where this gives an idea that where the students are going to get more job opportunities. And this is the survey in 2024, whereas in 2022 the more was around 66%, and remaining were for the more than more power, analog, and opto and sensors areas. But now it is increased to 73%. So that is also another point to observe. Yeah. So this is a bit more technical. In this presentation I would like to go non-technical, avoid more technology into this, as it covers the opportunities part for startups and students alike. So I'm not going deep into this, but technology in the sense we have mentioned as 5 nanometer, 7 nanometer, etc. These are the gate length. The gate length here is the transistors basic. We use MOSFETs and CMOS logic for this, and the gate length are this or expressed as nanometer technology. And the idea here is we are trying to reduce the gate length. We keep reducing, starting from now the Tata now the SEL Mohali has 180 nanometer technology node, which means the gate length there is 180 nanometer. And now it has further come down, and it is 5 nanometer and below are also available. And when it is 7 nanometer and 5 nanometer, it is not exactly the length, but it is the capability, which is equivalent to the 5 nanometer or 7 nanometer gate length. So it's a little bit technology oriented. But I'm happy to answer any questions on this in the last section. Okay. So why semiconductors? Now we would have got some fair idea about that. So what is the it is a $600 billion industry, and maybe now even more than that. And how many chips are shipped? Chips here is integrated circuits or microchips. And every smartphone has 5 to 8 chips, and most of the people own one or more than one smartphone. And a modern car has 3,000 to 5,000 chips. A data center server has 50 plus chips. And another important point to note is AI/ML expansion or explosion. AI/ML explosion, and because of that, NVIDIA's AI GPU revenue has grown to 2.5 times compared to 2024, etc. All these are entirely chip driven, and it's because of this AI's explosion. The semiconductor industry is suddenly booming up. It's not that it was not there before. It is the sudden boom is because of this AI/ML explosion, thanks to the AI. And also there are many policies have come up in them, like in regard to national securities. So US has US Chips Act, and European Union has its own Chips Act, and which is around $43 billion valuation. And India Semiconductor Mission, of course, we all know that it is 76,000 rupees crore. And so the chips are geopolitical. Next, coming to the climate impact. So when we consider the climate impact, solar inverters, electric vehicle motors, wind turbines, wind power, etc., everything require advanced power semiconductors. Now, what is our India semiconductor mission here? So why India needs a semiconductor mission here? There are 3 reasons. One is the first one is the strategic importance, which we have seen in the previous slides. And second is tremendous global demand driven by AI, electric vehicles, data centers, IoT, etc. The third is In the global sector, in the global level, significant talent requirement is there. Okay, so that is another important factor. And the industry is expected to continue growing for another decade. And so the objective is to build a strong semiconductor ecosystem covering design, manufacturing, packaging, research, talent development, and innovation. All these things we will be addressing in the next coming slides. Okay, so this India semiconductor mission. So now there is a question that is it the first time India is stepping into something called semiconductor industry? No, that's not. The answer is no. India was already there into this. The Semiconductor Laboratory (SCL) in Mohali, Chandigarh, was established in 1984 to build indigenous Indian chips. But due to some mysterious fire happened in 1989 that gutted the complete facility and devastated the operations and production for a decade. And it is being rebuilt again, to start. But by then, by over a decade, the rebuilding efforts and funding were severely delayed, and the production did not resume until late 1995 or 1997. During this decade-long hiatus, the global semiconductor market exploded. So the companies like TSMC, Taiwan captured massive economies of scale and advanced their technologies to a very different level, leaving SCL struggling to catch up. But currently, SEL, now if you ask, is SEL functioning now? Yeah, yes, it is. It is functioning now. SEL is currently operating as a research institute under the Ministry of Electronics and Information Technology, and it provides foundry access utilizing 180 nanometer fabrication nodes. So this 180 nanometer currently is not for the market; it is for research and development purpose and for the to turn the students' designs into reality. And there are further, you could see from the slide that there are further, the timeline, what has happened and what is currently now with respect to this. And there are a lot of initiatives taken by the country for incentive schemes, and many things are happening around this. At this In this slide, I would like to spend some more time on this particular slide because this covers the complete semiconductor industry and the value chain. Now, initially, if you see the very first part here, which is the system design, you can consider one example of the system design as, say, Apple. Say Apple wants to make a new iPhone edition or something they wanted to make. If they and say they have some plans or some ideas in mind, like these are the requirements and this is how the features are to be inside in the new edition. So that is the original equipment manufacturer. So here Apple is the original equipment manufacturer. So their idea is now will be given to any IC design company. Either they can own an IC design company, which you can see as the second one in the slide. Either they can own their own IC design company, or they can give it to some, they can outsource this to some IC design companies. Example, Qualcomm, etc. NVIDIA, Qualcomm, etc. So what they do is they take up the requirement things from the original equipment manufacturer. See, for example, the Apple, they will design how the processor has to be, how the memory devices has to be. They will do the complete design and turn the idea into a GDS file, which is which the fabrication unit can understand and manufacture from that file. And here, at this part of this, the IC design, if you look at the system design and IC design, India was already there in that. There were people working in those areas from India, in India, and under those companies like Qualcomm, AMD, etc., Intel. Many companies are there who does all these things. And so I mean, India has talents in these areas. India has already stepped into these two areas. And the next is after the IC is designed, the IC has to be fabricated into the physical silicon. So, silicon wafer, the idea or the IC has to be, chip has to be fabricated or made on the silicon wafer. For that, we need foundry or a fab. I will tell you what is the difference between foundry and fab. But now we need some facility, so or a plant or a factory to convert this the software file GDS2 file into a physical real IC integrated circuit. That foundry or the fab, that particular factory needs a huge billions of investments, and it needs a very clean room environment for the operation, and a lot of things involved in, and then a lot of heavy machineries to maintain that clean room, etc. And that India was not having before. So what will happen to the design? Where will it go? After the designs are sent to outside India for manufacturing. One example is TSMC Taiwan. So where this file will be sent there, and they will be fabricating this, and they will send back the die or wafer with the chip on it. The next step is the die or wafer will have many chips. It is not one single chip in a wafer. Wafer you can consider as a CD player. That CD, it will be considered as an example. Okay, that wafer will have multiple chips in it, so that has to be diced. So the next step, what is needed here is the chips has to be diced, and we will take out the chips, and those die, each and every die will be one single chip, and that has to be connected to the wires, external wires, leads. After that has to be tested, and then it will be packaged on the ceramic or plastic packaging. And the final IC, what we see is the packaged one after all these process. So we don't see actual die or the wafer or die in that. So what we see is the final finished IC with the packaged one. Now the next step is so this comes under the IC fab, IC packaging, and the next part is assembly. Assembly is nothing but once this IC, you can look at the IC here, the black color part in the above the assembly. If you can see my cursor, above the assembly there is a picture and there is a black color part. You see, right? Those are ICs, which are packaged ICs. It has gone through all these processes and has come to this level. And these ICs are soldered on the printed circuit boards. So this assembly India was doing before. There was something happening on this part also. So, but not completely, but some parts we were doing before. And after assembly, then packaging with the outer cover of the mobile and etc., the screen, etc. So that is the final product. India was also doing that part also. So where the gap is. So all these were there. The gap is now between this IC design and the final product. So the three things which India was not doing before are the IC fabrication, and then IC packaging, assembly. Now this particular thing, this was the gap. And now with this India Semiconductor mission, this gap is completely filled. And now there is an alternate path. Earlier it was going to China for these three things, China or Taiwan. Now, straight from system design till the final finished product, India is capable of. And who has filled that gap is, say for example, for the IC fab, Tata, in association with PSMC Taiwan, and that is establishing a fab in Gujarat. And that as I told, it is 28 nanometer technology. And of course, with the new sign up with the Netherlands company, we are getting the advanced lithography device so that we can go for sub-technology node also in Tata in the next level. So now a little bit of definition part. If we see, I see you're clear with. If you have any questions, please keep it for the last regarding this. Now at this point, I wanted to explain one more thing here. We have something called fab and foundry. So that is the thing. Foundries are foundry. One example is TSMC Taiwan. Foundries, they do not design the chips. They will only take the file from the IC design company and they will fabricate the chip on the wafer, on the silicon wafer. So only this is done by the foundries. Whereas fabs are nothing but if the company who designs the ICs also owns the foundry where they design and they fabricate their own IC, they are called fabs. So that is the difference. And what Tata is going to building here in Gujarat is a fab. So which means it is going to do both design and also the fabrication on that. And the next part is in IC packaging. When you see, there are two terms here in the IC packaging as one is ATMP, another is OSAT. So what is this? And so assembly is that part which is connected with the wire bonding. And next is testing, where testing we will be checking for the functionality of the IC, whether it is properly wired and is it properly functional, and is it doing its work or not. The third part is marking. Marking is nothing but writing what is this chip, some code or a batch, etc. Something. Marking. And then the last one is packing. Packing is a flimsy small chip, and that has to be protected from the external harsh environment and corrosion. So we keep it inside a plastic or a ceramic one. So that is the packaging part. Next. So this is a very, very important phase without which there is no, we are not going to get the final chip at all. Now, if the company, so what is OSAT? OSAT is nothing but the outsourced one. So these companies are specialized or third-party vendors. These are hired by the semiconductor companies or chip manufacturers for handling this ATMP process. So this is something. It's not the same unit of the. It's not a unit of the company who designs and fabricates, but it is a third-party one. Okay, so I think I almost okay. Next, coming to the electronics manufacturing services, we need some kind of equipments are needed in this case for the fabrication unit, as I mentioned. One of the thing is lithography device, which writes the IC design gates, etc. on the wafer. That is a very, very complex thing, and it needs a very high precision. And that device, that segment, the equipment and materials manufacturing segment, that is not there in India. We are getting it from outside. For example, the ASML from ASML Netherlands, we are getting the EUV lithography machine, which is a very high-end machine. EUV means extreme UV lithography machine. So that is very important to go to a smaller, lower technology, high-end, lower technology node manufacturing. Next, of course, I covered all this part. So, what are the things which are coming up now in this wave of ISM? Is the Tata Electronics and Micron Technology and CG Power? These are the things which are coming up here. So, of course, you can see the gaps filled up by these projects here. So the semiconductor gap is now filled, ecosystem gap is filled. Of course, yeah. What is it? 76,000 crore push, and where is it impacting? One is in the fab scheme, fab is for the fabrication part, and then OSAT or ATMP scheme for the companies which are establishing this OSAT or an ATMP. As I said, OSAT is outsourced. They can do ATMP process of any company. Whoever comes, approaches them, they will do it for them. But ATMP means it is only for the particular company who is designing, and it is only it is something like for in use, in-house purpose. And yeah, so and also the advanced technology like compound semiconductor, they are also gaining traction now, and could see the benefits they are getting from the India Semiconductor mission. And also there is something called design linked incentives. So this is the part which we importantly needed for the startups at low investments. And okay, and then there is one more gap. I addressed almost the entire semiconductor ecosystem, where there are two more pain points which are to be addressed yet. One is things are ready. We have to talk about the talent. So we need talents from India to work on these areas. So that would be our next topic about when we talk about the students opportunity. And for that also, India Semiconductor India Mission, they are working on this, changing the curriculum of IITs and ITs, and upgrading, enhancing the curriculum, and also setting up many labs. So for startups, what are the areas where the startups can contribute is, they can contribute in the chip design, AI hardware, semiconductor, IPs, embedded system sensors, packaging technologies, electronic manufacturing, and EDA tools. So these areas they can, and government support programs like, as I said, design linked incentives greatly help them in this case. But why we need startups here? India may not immediately compete with the global giants in the advanced fabrication, but startups can definitely faster this one and help India in this. How much time I'm left with? Yeah, thanks. So this is the semiconductor value chain. I would explain where the startups, what are these, and where the startups will get an opportunity here to work on. The very first one is IP and EDA. EDA is electronic design automation. This refers to the specialized software or hardware tools used to design the microchip. In semiconductors, this IP is not that intellectual property or the copyrights, these things. Not only that, but it not only just refers to the patents and copyrights. It also refers to the pre-designed reusable blocks, building blocks of the circuitry, and that engineers plug in. So these can be directly plugged into and easily design the chips to save the time. And this is the best option. It's a good area for the startups because it needs less investment. It doesn't need a heavy investment like fabrication units. And a good knowledge in C++, and excellent circuit knowledge, electronic circuit knowledge are the main investment required for this area, for this IP and EDA. Say example is they can develop agentic AI for chip design automation, or any domain specific chip designs for agriculture, etc. So those can be done, and also there is a huge market available for students in this. The next is ICDC in government schemes like DLIS, as I already mentioned, design linked incentive schemes, where up to 50% of the investment is borne by the country. And the tool access for those are also provided for the startups. For example, fab project tools are available in IIT Hyderabad. Wafer fabrication, this particular part it is really difficult for the startups to get into because it involves a very high investment and very precise, and it is very much clean room oriented, and establishing this clean room, maintaining it is a very very difficult challenge for startups. So that is one point. Um, and I mentioned there are two areas which we have not addressed. One is the students, the talent part, which is in the ecosystem, and there is one more thing which is the discipline part. That is where the fabrication part. So in the fabrication part, fabrication unit, it involves. It has to have extremely clean room. So it's okay kind of attitude will not work there. Anything will not work there. So fabrication has to be proper, otherwise entire system is going to collapse. So that is one important thing where the student community and those who are entering into this domain has to definitely have to follow that. The discipline is very important. So how you have to be there in the fab, how you have to work, what you need to do, that definitely we have to follow. So it's okay only for this day will not work here, and that's going to be a huge cost, not a just simple thing. Okay. Yeah. So moving to the next slide. So 3 business models. This is the last slide for this slide for the startup community. 3 business models in semiconductors. One is fabless, which I have already explained, where only the companies will design the chips, but they won't do the manufacturing or fabrication of the chips. And this is one good area for the startups to invest, because the investment is low, and our nation is also giving a lot of incentives in this area, where you can create IPs or you can design and do. And the pure play foundry, where only manufacturing will happen, design will not happen, where IDM is integrated design. Okay, let's move to students category. What are the opportunities the students are going to have in this semiconductor mission? So this is the vision of India in 2030. You could see that what is the target, manufacturing target, and what is the talent pipeline needed, and what are the design incentives. So looking at Tata, Micron, CG Power, etc. Everything, all these players will need thousands of process engineers, test engineers, packaging engineers, etc. from around 2025 to 28. And those who are graduating in this period, 2025 to 2028, are right into the demand wave. And also India's chip design center count grew from 20 to 110 plus. From 2015, in 2015 there are only 20 were there, and now it is 110 plus are there. Bengaluru, Hyderabad, Pune, Chennai, NCR, etc. are hiring constantly in this domain. So what are the skills and tools to start learning right now for the students? I hope there are some students are also available in this in this meet. So you don't have to wait for graduation and then start with preparing all these things. You can parallelly start all these things, from first year or first year end or second year onwards. So HDL and digital design in very log languages. These are the languages, and build small modules using these languages. And then FPGA hands-on. So there are free tools are also available for the FPGA, and you can build small projects. Starting from the small projects, go till the RISC-V architecture building, and that is a very valuable one for the students. And then there are many academic access also for the EDA tools. You can approach your college to check with if the college has any collaboration with any of the EDA tools available. And then Of course, Python, chip design, etc. Python is very much needed for chip design. You cannot rule it out. And there are other open sources things and Linux scripting. So, how can the students connect and how do they get to know about the things? So, connect first, learn, connect, share, and lead. So, be in these things, connect with uh, other peers in LinkedIn, and be a part of IEEE, etc., and participate in many presentation, etc. Meet industry leaders, attend the conferences. Okay, all right. So after you complete, what are the career paths in VLSI and semiconductor? So it can be these many options are available where digital design is very common, and there are a lot of job opportunities in this digital design. So what are the prerequisites for this digital electronics and computer architecture? These are the prerequisites, and Verilog, any scripting language, Verilog or VHDL. Then is the analog and mixed signal design where more analog circuits and circuit knowledge is very much important for this particular analog and mixed signal area domain. Physical design and layout for the timing analysis, all these things are very. This is another area, and these are the multiple areas available under VLSI. So, based on your interest, you can choose one path and you can start from the beginning. So no need to wait for graduation and then start working on this. Yeah. So when is the right moment? It is now. Opportunity is right now. Utilize it. And thank you all. With this, my slides are over, and you can connect with me in this for more on VLSI and semiconductor industry. Any questions, or do I have time for that? Or
Thank you, ma'am, for your explanation. You have made a perfect PPT because we are not from technical side, but you have made it easy. And what the important aspects of that speech, that is how India is ranking or how the semiconductor industry ranks scope for the students from manufacturing, packing to the export. So every point of this you have explained, and now this dais is open for the participants. If someone wants to discuss with our speaker, they can. Kindly unmute yourself and you can discuss with our speaker. Dr. Swanand
yes.
Shrivastava, please.
Good evening, Dr. Betkar, sir. Good evening, ma'am. Thank you for wonderful presentation. We are not from the technical field, but still, we could understand some part of it definitely. And I think, when we are talking about semiconductor, these are the very important part. And, because our Honorable Prime Minister is insisting about the, going for this semiconductor development and the chips development, microchips development in our country. I remember some in Assam also, they have promoted some industry over there regarding this. And we are having a kind of a collaboration with some countries. So this is a wonderful thing what we are talking about. But I think, we are, at least I'm listening this word since my childhood, conductors, semiconductors. So that time conductors and this time conductor, is there any difference between these two? Because we used to open the transistors and radios, to something, explore some knowledge, from where the sound is coming. So we used to find out. And some people used to tell us, this is semiconductor, this is conductor, this is gone. So is there any difference between these two conductors, 20 years back and today's conductor? That is my first question. And second question is, if suppose, means whether we should go with startup because it consumes a lot of financial burden, So should we go for startup studies, or maybe the established companies which are doing very well in a crores, they can enter into this market. So which one is the easier one? Thank you, ma'am. Please answer.
Sure, sir. Regarding your first question, conductors and semiconductors, if you are looking for the difference between conductors and semiconductors, conductors are just metals or anything where current can pass through. Where semiconductors needs a certain condition, only in that particular condition, it allows the current. So let's not discuss deep about this one. So just for everyone to understand. So we need certain conditions. So we can basically control the current flow through semiconductors. So we have a hold on it, so we can control it. So, and as you said, 20 years back, that semiconductors, the transistors, what you were talking about, those are bipolar junction transistor or BJT. So we were using that before, and now what we are using is MOSFETs. So that is the advancement. And even in the MOSFET also, we started with planar MOSFETs, and now it is the overall idea of this reducing the size of the semiconductors here, that is very important. So power, performance, and area are the matters here. So we want to reduce the power, we wanted to increase the performance, also we want to reduce the area. So we go for the next technology to MOSFETs. In MOSFET also it was planar MOSFETs earlier, and now there are a lot of advancement, and now we are stacking the transistors one upon the other rather than spreading it, so that we can reduce the area. So for that we have gate all over FET, etc. Lot of different things are there. So GAFET, etc. are there. So that is the technological difference now, compared to earlier one. And not only the transistors part alone, MOSFETs alone, we are working on using a different combination of semiconductors to achieve these PPA things. Some advancements are also happening, like gallium nitride, etc. we are using for specific purposes. So that research is also going on now. And your second question, I'm not clear which domain you are talking about exactly in that. So the players you were talking about for the step between the startup and those who are already having, right? So which particular segment, if you are asking, it would be helpful for me.
So I'm asking about that the person who's new in the market and he want to start up the program, that will be easy for him, for if you are going for some project of semiconductor, or people who are already in the market, Tata and Adani group and this group and that group. So if they are already existing, they are having established all these things, whether it will be easy for them.
The people like Adani and all, definitely it will be easy for them, where when they have the money, it is easy to start. But again, what is more important is for it to run properly, because it is a huge investment to run properly. The proper talent is important there to run it. So the knowledge is also equally important, without which it is difficult. So there should be a balance.
Yes. So there should be a technical support also, and sound knowledge behind to start any project. Of course, any project we require a sound study. If it is not there, the consistency will not be there, and such a huge investment will get collapsed then.
Yes.
Perfect. So I could understand that semiconductors are like a nerve conductor in the human body. So they transmit the messages as well as they modify the messages or whatever, So that is how they are playing a role. So I think semiconductors are there in our smartphone. They are in the computers and the televisions and so many places in the space technology, and at least means even in biomedical, some machineries we are also having semiconductors. So yes, definitely it is very prime thing, and we should promote this kind of. So it is a new, what we can say, place scope, for us to grow further. So definitely India will exceed, because all Asian countries, South Asian countries are doing very well in that. So no doubt, if we will put our energy for this, and if there is a support of the government for some projects and some, subsidized form, if they are getting some help, So that will become easy for India also to build this semiconductors. So
Of course,
silicon
there are a
based.
lot of schemes available. The country is giving a lot of schemes to help all the segments, in all the segments, whether it is an IP, an EDA, or fabrication unit. So government is having some incentives for each and everything, for manufacturing also, for design also. It's available. So that is what that push is now.
So the boost is coming from the government. That is good thing.
Yes.
And what future you will see, of semiconductors after 10 years, 20 years?
Some 20 years back, how India was. 25 years back, when the IT software engineering just it was starting. That's where we are now in semiconductor line. So the same wave you can expect for semiconductor also.
So we are the beginners.
Yes.
So thank
At
you
least
very
now
much,
we
ma'am.
should step into.
Yeah, thank you very much for your wonderful explanation. Thank you.
Thank you, sir.
Thank you, Dr. Sanand Shukla, sir. We get knowledge through your discussion today also. Thank you for actively joining and actively discussing with our speaker. Thank you, ma'am. As you are director and founder of DigitCodemy, so how students can approach to you for projects or any help from you for their startups or any type of help from your academy?
They can connect with me in my LinkedIn profile and they can message me for immediate response, or they can connect through the website and they can connect with any of my associates through website and reach out to me. That is also possible.
Thank you, ma'am. We will send this message to the students who are in IT sector. They can take help from you and they can create their career in future also. Thank you, ma'am, for your valuable time sparing for us with this technical session and useful session for us, because it is related to students' innovation, startups, which is need of this hour. And thank you again from our participants and from organizations. In future also, you will be here as a speaker on different topic as per your convenience. Thank you, ma'am.
Thank you all here for your patience listening to me and cheering me. And thank you, Dr. Betkar and Veer Maheshwar Charitable Trust for this opportunity.
Thank you, ma'am. Thank you. Participants are requested to fill the feedback link and give their feedback so that they can receive their certificates. I am thankful to all those who have joined here today, as every day. Today, thank you to you.